Welcome back, everybody. Today, in Science 9, we are going to be talking about potential difference. We're going to go into voltage, and we're going to talk about some calculations. We're going to try to do some calculations. So what do we know so far? Well, if we remember from last class we talked about current, which is denoted by the symbol I. We talked about what current means. So current, if we remember, is the amount of charge divided by time. Our amount of charge is in coulombs, unit coulombs, and our time is in units seconds. So coulombs per second gives us our current, which is in units amps, right? This is nothing new. We talked about this last class. What we're going to learn today is we're going to derive a formula for potential difference. We're going to look at what potential difference is, and we're going to do some calculations in regards to potential difference as well. So potential energy. What is potential energy? Well, potential energy is the energy due to the position of an object in a field that the object interacts with. Now, what does this mean? What does this mean? Well, let's draw a little diagram here. So this is me here, Dr. M. And I'm holding a ball on top of a hill. At this point, the field that the object interacts with. So right now, the object is the ball, and the field is the entire system. So me standing on top of a hill, holding the object again, which is the ball. As I drop the ball down the hill, the object is then interacting with the field. So at this point here, in our first picture, the ball has high potential energy. The ball has high potential energy. And we say potential energy because it has the ability to do work. It has the ability to convert its energy, which it is standing on top of the hill holding the ball. It has the ability to convert that into kinetic energy. So as I drop the ball down the hill, we have low potential energy. Oh, ran out of space there. That's okay. Low potential energy. But we have high kinetic energy. We have high kinetic energy. So the potential energy is being converted into kinetic energy as the ball is falling down the hill. So this is another little example. The entire system, or the entire field, consists of a container at the bottom filled with water. It consists of a pump, a container at the top, and a water wheel that spins when it interacts with water. Great, so that's the field. But what's going on here? So at the bottom, water does not have the potential to carry out any work, right? It has a low potential energy. Has low potential energy. As the pump carries the water up into the second container, that low potential energy changes. So now the water has high potential energy. It has high potential energy because it has the ability to carry out work on the water wheel, converting its potential energy into kinetic energy, returning back down to its low potential energy state. What is potential difference? Well, potential difference is the difference between potential energy per unit of charge at 2 points in a circuit. So the important things here to remember, it's at 2 points in a circuit. So there's no potential difference if you're looking at a single stationary point. There's no potential difference. So potential difference is also referred to as voltage. You might have heard this term more. than potential difference, but these terms are interchangeable. So voltage is the difference between potential energy per unit charge. So the difference between potential energy per unit charge, right? So these terms we've known before. Q being our total charge, and that's measured in coulombs. Energy, we haven't talked about much before, but energy is described as joules. So our voltage, our units for voltage are simply joules per coulomb. Okay? Now joules per coulomb is also just volts. So our voltage is in units volts. But this is the formula that we need to remember. That voltage is equal to the energy divided by the total charge. Let's try some examples. And we're going to go ahead and use our guess method for all science related questions. So the questions ask us to find the unknown quantity in this example. So G, what is given? Well, we have energy to be 45 joules. And we also have our total charge to be 13 coulombs. Our unknown is our volts, our voltage. The equation that we're going to use is simply our voltage is equal to our energy divided by our total charge. So now we're going to go ahead and solve for our voltage. Our energy is 45 joules. And our total charge is 13 coulombs. So 45 divided by 13, our voltage is equal to 3.5 volts. Great. And now our statement at the end. So therefore, the voltage of the system is 3.5 volts. So the important thing here is we don't want to forget our units, right? So joules per coulomb is simply volts. So let's go ahead and try one more example. In this question, the potential difference between two terminals on a battery is 5 volts. How much work is required to transfer 12 coulombs of charge across the terminals? Again, going through our guess method, what is given? Well, we're given 5 volts, and we're also given our total charge, which is 12 coulombs. Okay, now what is our unknown? Well, our unknown is how much work is required. So our unknown is our energy. The equation that we're going to use does not change. We have volts is equal to energy divided by our total charge. Solving for energy, rearranging for energy, we have energy is equal to volts multiplied by our total charge. And now we'll go ahead and solve. So energy is equal to volts multiplied by our charge. So we have 5 volts multiplied by our 12 coulombs, giving us a final answer of 60 joules. Right, so if we do unit analysis here, we have energy is equal to our volts multiplied by our coulombs, and volts is joules per coulomb. And if we're multiplying by coulombs, our coulombs cancel out, and we're left with energy is equal to joules. So there we go. And our therefore statement, therefore, the amount of work required is 60 joules. Great. We now know how to solve potential difference questions